Have you ever wondered what it would be like to colonize the sun's surface? A curious question, isn't it? The sun, a giant ball of gas and plasma, blazing with heat and radiating energy that is both life-giving and potentially destructive. At first glance, the idea seems not just impossible, but downright absurd. Yet let's entertain this concept for a moment. Imagine, if you will, a civilization that has advanced to such an extent that it can contemplate and even seriously consider the colonization of the sun. A civilization that has conquered the challenges of living on planets and moons and now looks to the stars, not just for energy, but for real estate. But what would life on the sun look like? How would we protect ourselves from the extreme heat, the intense radiation, the magnetic storms, and the constant nuclear fusion happening all around us? Would we live beneath the surface, shielded by layers of superheated plasma? Or would we float above the surface in structures designed to withstand the sun's fierce conditions? These questions lead us into uncharted territory, into realms of science and technology that we are only just beginning to explore. The challenges are immense, of course. The sun's surface temperature, for instance, is around 5,000 degrees Celsius, hot enough to vaporize any known material. Its magnetic field is incredibly strong, capable of causing enormous solar flares. The radiation is intense, far beyond anything we experience on Earth. Yet, despite these seemingly insurmountable challenges, the idea of colonizing the sun is not entirely without merit. The sun is, after all, an abundant source of energy. Harnessing that energy directly and on a large scale could potentially solve many of the energy problems we face today. But how could we possibly survive, let alone thrive, in such an environment? The answer, as with many things in life, lies in innovation, creativity, and a willingness to push the boundaries of what we believe is possible. Stick around as we delve into the mind-boggling concept of sun colonization. To understand the challenges, we first need to understand the sun. The sun, our closest star, is a celestial body of immense power and energy. It's composed primarily of hydrogen and helium, with trace elements of heavier materials. These elements are churned in a relentless nuclear fusion process that powers the sun and gives it its radiant glow. Imagine a sphere of hot plasma with a diameter about 109 times that of Earth. That's our sun. Its core temperature reaches a scorching 15 million degrees Celsius, hotter than anything we can comprehend. This heat generates a pressure so intense that it forces hydrogen atoms to fuse, creating helium and releasing energy in the process. This is nuclear fusion, the power source of the sun, and it's this energy that lights up our sky and supports life on our planet. But the sun isn't just a giant, glowing ball of gas. It's a hostile environment teeming with radiation. The surface radiates light and heat, but it also emits a stream of charged particles known as the solar wind. This wind can reach speeds of up to 800 kilometers per second, creating a dangerous environment for humans or any kind of life as we know it. And don't forget about the sun's magnetic field, which is about twice as strong as Earth's. This field is responsible for the sun's solar flares and coronal mass ejections, which can send out bursts of radiation that could be lethal to any nearby organisms or technology. In terms of size, the sun's vastness is staggering. It's so large that over 1 million Earths could fit inside it. It's a behemoth that dwarfs our home planet and makes any concept of colonization seem like a far-fetched dream. Knowing these, one might think colonizing the sun is impossible. But is it? Science has taught us that the impossible can become possible. This is not just a saying, but a living truth that has shaped the course of human history. Let's take a stroll down memory lane and revisit some of the groundbreaking scientific achievements that once seemed implausible. Think of the Wright brothers, two ordinary bicycle mechanics who dared to dream of human flight. At a time when mankind was earthbound, they unlocked the secret of the skies, transforming the impossible into reality. Fast forward to 1969 and we find ourselves gazing at the moon, not as a distant celestial body, but as a destination. Neil Armstrong's famous giant leap for mankind was a testament to the power of technological advancement and human aspiration. Even more recently, the advent of quantum computing appeared to be a figment of science fiction. Yet here we are on the brink of ushering in a new era of computation where problems that would take traditional computers millennia to solve could be unraveled in mere seconds. Each of these examples serves as a testament to the power of innovation and technological advancements, They remind us that the boundaries of possibility are not set in stone, but are malleable, ever-changing with the tides of human progress. Now let's bring our attention back to the topic at hand, colonizing the sun. Perhaps the very notion may strike you as preposterous. After all, how can we survive on a celestial body with temperatures reaching millions of degrees? But remember, there was a time when the idea of humans soaring through the sky or stepping on the moon seemed equally ludicrous. As we stand on the precipice of a new era, we must ask ourselves, what if the impossible is not so impossible after all? A question lingers in the air. Could we apply the same principles to colonize the sun? Let's dive into some theoretical approaches to colonizing the sun. To begin with, we know that the sun's surface temperature is around 10,000 degrees Fahrenheit. That's hotter than anything we've ever encountered. However, science has been making strides with materials that can withstand extreme heat. For instance, researchers have developed a ceramic composite that can endure temperatures of over 4,000 degrees Fahrenheit. It's not quite sun-ready, but it's a start. The next hurdle is the sun's intense radiation. It's 1,000,000 times more powerful than anything on Earth. A potential solution could be energy shields. Now I know what you're thinking. Energy shields like in Star Wars? Well, kind of. Scientists are studying the possibility of using magnetic fields to deflect harmful radiation. It's a long shot, but it's not entirely out of the question. Then there's the idea of living within sunspots. These are areas on the sun's surface that are cooler and less intense than the surrounding areas. They're still hotter than anything we're used to, but they're a relative oasis in the inferno. The idea would be to create structures that float above these areas anchored by magnetic fields. Of course, there's the question of energy. The sun is a massive nuclear fusion reactor constantly converting hydrogen into helium. The energy released in this process is mind-boggling. Harnessing that energy could provide the power needed for life on the sun. And then there's the question of time. The sun is constantly in motion, with its surface churning and roiling. Any colonization effort would need to account for this with structures that can adapt and move with the sun's surface. All of these ideas are, of course, purely theoretical at this stage. We're a long way off from being able to put any of them into practice. But it's fun to imagine the possibilities, isn't it? These theories may sound like science fiction, but who knows what the future holds? The road to sun colonization is fraught with challenges. Now, let's delve into some of these challenges and explore what it would truly take to make this audacious dream a reality. Firstly, we must consider the logistics of transporting materials and people. Imagine the sheer magnitude of resources necessary to construct and maintain a colony on the sun's surface. Not to mention the technology to safely transport personnel and supplies across 93 million miles of space doesn't currently exist. It's a Herculean task that would require unprecedented levels of international cooperation, technological advancement, and financial investment. Next, we have to address the need for sustainable life support systems. The sun's intense heat and radiation present unique obstacles for the creation of a habitable environment. How do we create a system that can provide the essentials, air, water, food, in such an inhospitable environment? The solution lies within the realm of advanced material science and bioengineering. We would need to develop materials capable of withstanding the sun's intense conditions, and perhaps even bioengineered organisms that can thrive in such an environment, recycling waste into usable resources. Moreover, the potential impacts on human health are a significant concern. The sun's extreme conditions could lead to a host of health problems, from radiation sickness to the effects of prolonged weightlessness. We'd need to understand these effects fully and develop effective countermeasures to ensure the safety of sun colonists. And yet, despite the myriad challenges, the prospect of colonizing the sun is not without its allure. Each challenge presents a puzzle to be solved, a hurdle to be overcome. And in the process, we may just stumble upon new technologies, new scientific understanding, and new ways of looking at our universe. These challenges are daunting, but they also present opportunities for innovation. Every problem is a door to a new solution. Every obstacle a stepping stone to a new discovery. So, as we look towards the future, let's remember, the journey to the sun is not just about reaching a destination, it's about the innovations and discoveries we'll make along the way. What could the future of sun colonization look like? A fascinating question indeed. Let's dive in. Imagine a future where we've mastered the art of harnessing the sun's limitless energy. No more dependence on fossil fuels or the need to fight over dwindling resources. Instead, we could tap into the sun's power, creating an era of clean, abundant energy. This would revolutionize our economies and societies, not to mention drastically reduce our carbon footprint. But the benefits could go far beyond energy. Sun colonization could open up new frontiers for scientific discovery. We could study the sun's processes up close and personal, gaining insights that could revolutionize our understanding of the universe. Imagine the breakthroughs we might make, the knowledge we could uncover, and then there's the survival of the human species. As Earth's resources dwindle and our population grows, we may need to look to the stars for our future. The sun, our closest star, could provide us with the space and resources we need to thrive. It could become our lifeboat, our ark, our new home. Yet, with these potential benefits come important ethical considerations. Should we colonize the sun if it means disrupting its natural processes? What impact might this have on the rest of the solar system? Who would get to control this powerful new source of energy in space? These are questions we need to grapple with before we set our sights on the sun. The future of sun colonization is a tantalizing prospect, full of potential and fraught with challenges. It's a journey that will require our best scientific minds, our most innovative technologies, and our deepest ethical reflections. The prospect of colonizing the sun raises many questions, and only time will reveal the answers. But one thing's for certain, it's a journey that's bound to be one of the most exciting chapters in human history. As we've seen, colonizing the sun is a concept that stretches the limits of our imagination. We've journeyed together through this thought-provoking exploration, unearthing the realities and possibilities of an idea that seems both fantastical and formidable. We began by pondering the impossible, questioning the very thought of setting foot on a celestial body that is not a planet or moon, but a star. A star that's a blazing ball of hot plasma, radiating energy and light. A far cry from the solid ground we're accustomed to. We then took a closer look at the sun, delving into its fiery depths, its intense heat and gravitational forces. We explored what it would mean to live in such extreme conditions, the technologies that would be required, and the radical adaptations we'd need to survive and thrive. We considered the art of the possible. We examined theoretical approaches, from creating heat-resistant materials to harnessing the sun's energy for sustenance. We contemplated the construction of solar cities floating above the sun's surface, powered by the very star they orbit. We acknowledged the challenges ahead. The technological, physiological, and psychological hurdles are immense. But we also recognize that these very challenges drive innovation, inspire creativity, and fuel our determination to reach beyond our known boundaries. Finally, we envisioned the future of sun colonization. A future where the impossible becomes possible, where we harness the power of the sun not just for energy, but for habitation. While colonizing the sun may seem an impossibility today, we must remember that once, so did putting a man on the moon. The future is full of possibilities, and our capacity for invention and innovation is boundless. As we continue to push the boundaries of science and technology, who knows what tomorrow may bring? Until then, keep wondering, keep questioning, and keep exploring the universe around us.